All right, my friends, as you can see on the screen, you don't see anything on the screen. We're going to have a blank screen here just for about half a minute while I warn you about the dangers of skimming past this part of the course as far as VPNs go. And by this part of the course, I mean the theory discussion, because we're going to have a discussion on theory and some very important terms and terminology when it comes to virtual private networks. And some of these terms get used interchangeably, and they're not. Some people think they know exactly what they are, and they don't, and you don't want to find that out on exam day. So even if you're familiar with VPNs, which you may well be at this point in your career, do not skim past this part and look for the labs. Now, what is a VPN to begin with? We're really taking this down to the fundamentals. What is it? Well, just a few years ago, a VPN was, a big deal. I remember it's actually probably been about 9 years or so since there was a site I worked at and some big wig in the company, none of those small wigs. One of the big wigs in the company would, want a VPN in, and it was like an event. We had to be ready for that. And of course, the tools available then weren't as good as they are now, and it wasn't exactly something you did every day, so it was kind of a pain in the behind. Kind of like voice and video traffic. It wasn't something you handled every day, so maybe your network wasn't ready to handle it. Maybe everyone in the network who works with your network wasn't ready to handle it. Well, today, they're so commonplace that it's like wireless. You don't even really think about it. You don't think, hey, this is really fantastic that I can do this. We just consider VPNs to be part of our regular network. Now, those of you who have taken a lot of my courses before, even just a few, you know that I say the name is the recipe fairly often when it comes to networking. Let me move that just a bit so we're not near the edge of the screen. There we go. And it's really the same for VPNs because it's so easy to remember that all these acronyms we use actually mean something. Well, what is a VPN? Let's take it down to the essentials. Virtual private network. Virtual, it's like a VLAN. It doesn't exist physically, but with this virtual, we mean it's a tunnel between two endpoints. And, we'll see later in this particular part of the course why that can be called a tunnel, because you hear them just called tunnels sometimes. And we'll chat about that a little bit later too. Now, private, it's open only to the two parties at the endpoints, we hope. We're going to work very hard to make sure that happens, and we'll definitely be talking a lot about that since this is a security course. Now, network, hey, it's a network. It is a virtual private network. Basically, what you're looking at here is a point-to-point wide area network. And as with any wide area network, what's one of the first things we were worried about once we memorized, what the default encapsulation on a Cisco interface was, serial interface that is, that kind of thing, we started talking about security. Remember that the default is HDLC. It's a Cisco proprietary HDLC, but since HDLC doesn't really have any built-in security, we usually use what? We usually use PPP or we use frame relay because we're concerned about eavesdropping. We're not just concerned with making sure that we're talking to the right person on the other end of the point-to-point connection. We're also concerned about, is anyone in the middle, a man in the middle, hintity hint hint, listening to this conversation. So we will be concerned about that. Now, the VPN type we're going to talk about primarily here is a remote access VPN. And that's where a user is typically connecting from their individual location outside the company, say, of course, from home. And you might think immediately, well, as opposed to what? Because if I'm not remote accessing, why am I VPNing? Well, what you could have is a site-to-site VPN, and that allows users at one company site to connect securely to another company site. And there may be another reason or two why we would do something like that. And I think we're going to see that here pretty shortly with our VPN Good Points. What's good about a VPN? Well, scalability and cost is far superior because you and I both know, we don't like full meshes, right? Because they're really hard to keep up with. They're not the most scalable solution in the world. If you've studied BGP before with route reflectors, everything, we're trying to prevent having that full mesh. Well, it's also terribly expensive and terribly impractical to try to build a private line between everybody at one site and then everybody at another site. I mean, that is not going to be something that really can happen in the real world. Another good reason for VPNs, and this refers to something I mentioned just a moment ago, if you were talking about a site-to-site VPN, for example, security policies can be enforced on the VPN without being enforced on any other communications between the physical networks involved. So you could have point A and point B and have, say, regular WAN connections over, PPP connections, whatever. Excuse me. And you could have one level of security there, but then for a particular VPN or a particular communication, maybe you need additional security. You could create a VPN and apply a security policy to the VPN without affecting the other communications going over the same wide area network. Pretty cool stuff. Now, here are those terms I was talking about. None of these are difficult at all. They should be very easy points for you on your exam because I can guarantee they're going to show up in one form or another. But don't use them interchangeably because they don't mean the same thing. Now, authentication, boy, that's something that we've been doing since our CCNA days, really since our CCENT days. And it's obviously a very important point when it comes to our VPNs because there's really no use in going to all the trouble and all the work of creating a virtual private network if we're not authenticating the user at the other end of the virtual private network. And for that, we're going to use a combination of ciphers and keys for authentication. More about that in just a few minutes. Now, data integrity. Authentication is important, but it's not enough. We learn about authentication at the CCNA level and at the CCENT level, and you probably had the same thought that I had. It's like, well, that's really all you need. Well, no, it's not enough. We also have to have a way to make sure that the data arriving on the VPN actually originated with the authenticated device at the other end of the VPN. Because again, someone can interrupt and be a man-in-the-middle type attack. We can't just concentrate on the two endpoints. We've got to make sure that nothing happens as data is going from A to B and from B to A. Now, sometimes it's called data origin authentication, and data integrity is achieved via the use of hashes. And you and I already have experience with hash results, because if you take a simple password in a Cisco router config, say the VTY line password, and then you turn on the password encryption service, you're going to end up with a hash result right there in the config. Now, that particular encryption, as you probably know already, is very weak, but it's still enough to prevent someone from looking over your shoulder and spotting it. But that is a hash. Luckily for us, we have some much stronger hashing algorithms available to us, and they all really work basically the same way. And here's how. First, the sender runs the algorithm against the packet contents and takes the resulting, whichever one you want to call it, hash value, hash code, checksums, or hash sums, and attaches that value to the outgoing packet. Excuse me. Now, the receiver is going to run the same algorithm against the packet contents. And if the result exactly matches the hash result sent with that data, then data integrity is assured. And if not, well, it isn't. But that's exactly how it's going to work. Now, confidentiality. This one does mean exactly what you think it means. Only the two endpoints can read the data. If anyone else sees it, it just looks like a bunch of garbage. It looks like a bunch of gobbledygook. Now, anti-replay protection and replay protection, they're actually the same thing. So you just have to get used to it. Whichever term you use, we really don't like replays. And you might say, replays of what? Well, replays of a legitimate, valid transmission. And you could look at that and say, well, how in the world can replays of a legitimate, valid transmission cause me trouble or cause my network trouble? Well, there's your dramatic pause, and then you see it's when they're sent by a network intruder in hopes of tricking a legitimate network device into thinking that the intruder is also a legitimate network device. So that's where it comes in. And again, it's replay protection and anti-replay protection. They are the exact same thing. Now, during your NA and CCENT studies, we talk a little about hashing. I shouldn't say a lot, but, we've got the MD5 digest going on. We've got link authentication with a couple of different protocols. Most of our attention, though, is on not sending information in clear text, right? We're all agreed that that is just about always a bad idea. But we're not really concentrating on what's going on with that hashing and digesting, etc. And that's fine with me at the CCNA level too, because we got enough to do there. But we're going to raise the bar a bit here with the CCNA security and actually talk about what's going on when we run a command like service password encryption. What is cryptography? What's going on, as I like to call it, behind the command. Anybody can enter a command, but not everybody's going to know exactly what's going on. And in the very next video, we're going to talk about cryptography. We're going to look at some methods of that, past and present, and then we'll hit the labs. And I will see you on that next video.